Testing 1, 2, 3. Did you hear about the scarecrow got a raise? No? He was outstanding in his field. Oh, was that a corny joke? Corny joke. So my student was on a basketball trip. He turned in all his assignments late. I said, you can't turn this. Mr. Leader, I was traveling. Well, he should get a foul. A foul. He was traveling. Okay, that's enough jokes for today. All right. So anyway, to calculate the probability that event A will occur, you need to know that the events are independent or dependent. Independent means that they happen independently, right? Which means like, well, we'll look at some of these examples. Well, let's not look at examples. Say I have 5 pennies and 3 dimes in a jar. 5 pennies and 3 dimes in a jar. What's the probability that I pull out a penny? 5 pennies and 3 dimes in a jar. 5 pennies, 3 dimes. How many coins do I have altogether? 8, right? So what's the probability that I pull out a penny on the first try? 5. What if I keep that penny in my pocket? Now what's the probability that I pull out another penny? 4, right? So the probability that I pull out another penny is 4 out of, there's only 7 coins in the jar, right? So now my probability is 4 out of 7. What do I do to figure out the probabilities of both of those events occurring? It's 5 times 4, which is 20 out of 56, and then you reduce it, which would be 10 out of 28, which is 4 goes into both of them. 4 goes in there 5 times, 4 goes in there 14 times. 5/14ths of the time you're going to pull out 2 pennies in a row. Get that? Yes? Now that's called dependent events, okay? Meaning one depends on the other. But if I put the penny back in, that's independent, okay? So what's the probability that I pick out 2 pennies in a row if I have the first try? My first try, what's my probability of picking out a penny? If I have 5 pennies and 3 dimes, still 5 out of 8. But if I put that penny back in, what's my probability of picking out a penny the second time? 5 out of 8. Those are independent events, right? Because it doesn't matter what happens the first time. And so then I multiply those probabilities, and I get 25 out of 64, which is different than 5 out of 14, right? So you have a better chance of, do you have a better chance?
Yeah.
Is that 25/64 better than 5 out of 14? What? A little bit better. Okay. So that's the difference between independent and dependent. So if I look at some of these problems, okay, and probabilities, you multiply them together, right? So if I have, for instance, let's see, probability, hey, what are you doing? Probability that the lottery, you know the lottery? Do you know how the lottery works? Do you know, anyone know? Me neither. I never play. You know why I don't play the lottery? Because I'm a math teacher and I'm smart to know that the odds are against me if I play the lottery. However, okay, I think when you play the lottery, you have to get like 5 numbers or something. Is it 5 numbers? But I think they put the number back in each time. I'm not sure how it works. I'm not sure if it's independent or dependent. I better not say it. Let's just look at this one, okay? So I shouldn't talk about the lottery if I don't know what lottery is. Okay, so let's go back. Where'd that sheet go? So say I have this. Let's do a couple of these problems. Place, capture, new. Oh. A bowl contains 5 red marbles, 6 green marbles, 9 blue marbles. If a marble is picked randomly and replaced a second is randomly picked, what is the probability that a blue marble randomly picked, replaced, and the second is randomly picked, what is the probability that a blue marble is picked twice? How many marbles do I have altogether? How many marbles do I have? Huh? 20 marbles, right? What's the probability that I pick a blue one? How many blue ones do I have? 9, right? How many, so if I put that back in, what's the probability that I pick a blue marble again? 9 out of 20, okay? Whoops, that's not a 9, that's a confused, so 9 out of 20. So the answer to that would be 81 out of 400. I don't think that reduces, right? Which is like, what is that as a percent? It's about 8, it is 8.1, is that 8 point? No. It's about 2, if I divide both of those by 4, right? 81 out of 400, it's about 20%, isn't that right? Because 81 times 5. Okay, a bowl contains 5 rare 6 green marble. If a marble is picked not replaced, what is the probability that a red marble is picked twice? So what's the probability of getting a red marble the first time? 5 out of 20, right? What's the probability of getting a red marble the second time if you're not replacing them? 4 out of 20, right? There's only 4 to choose, 4 out of 19, right? Not out of 20. And then you just multiply those together and you get that probability. You get that, Evelyn? What if there were no red marbles? How would you feel after that? If there were no red marbles, you know how you'd feel? You'd feel marvelous. Marvelous. This teacher's losing all his marbles, isn't he? Okay, let's move on. Jack, get off your phone. It's bad. Leads to cancer in laboratory animals. Okay? No, seriously. Number 15. So listen, what is the probability of a black card with, now we're getting into some card problems. What is the probability of selecting, so how many cards are there altogether? There's 52 cards. So when you're doing cards, there's a couple different ways to do it. What is the probability of selecting, without replacement, a black card, and then a heart, and then a diamond, in this order? What's the probability of picking out a black card out of a deck of cards? There's 26 black cards. So it could be either a spades or a clubs, right? Okay. Then, without replacement, then a heart. So now how many cards do I have in the deck? No, how many? But I only have 51 cards, right? And then out of those 51 cards, how many of them, you have to know a little bit about cards, right? So how many hearts are there in the deck? There's 13 out of 51. You get,
the black card though?
it can't be because hearts are red, right? Right? Yeah, I mean, you got to think about these, you know. And then a diamond. Okay, so now how many cards do I have to choose from? 50, right? If I picked, how many diamonds are there? Now there's 13 diamonds left, because if I picked a black card, then a heart, then a diamond, it'd be 26 times 13 out of this times this times this. I'm not sure what that is. I do have, where's the answers to this one? If I did that out, right, I would get, that's 169 over 1500. Comes out to be 169 over 5100. 5100, which is about 0.033, which is 3.3%. Okay, so do you have a probability of doing that? Okay. What's next? What is the probability without replacing a black card and a heart in any order? So this is kind of another. So these card problems, I tell you, they get really confusing, and I have to think about them a little bit. But let's see if we can figure out this one. And then we'll talk about the next part, and we won't talk about expected value. Maybe at the end of the period I'll talk about expected value. What is the probability of selecting without replacement a black card and a heart in any order? What's the probability of picking out a black card? 26, right? A black card, 26 out of 52, right? Without replacement. So now how many do I have to choose from? I have 51, right? And then a heart. So how many hearts are there? 13. But if they say in any order, I could have also picked out, so I'm going to add the probability of picking out a heart first, right? So what's the probability of picking out a heart on the first time? 13 out of how many? 52. And now how many cards are left? 51 out of, 51, and how many am I going to choose? 26. So really, do you see that this times this and this times this give you the same number, right? So all I really had to do, a shortcut to do this would have just been to go 26 times 13 out of 52 times 51 twice, right? Double that, right? And if I did that, I'd get about 25.5%. About 25.5%. Do you think you can handle some of these? They're tricky. They're fun though. Do you think these are fun? They're okay. Okay, so let's try to go through adding probabilities. So if events are mutually exclusive, okay, meaning like I roll a dice and I flip a coin. Those are mutually exclusive events, okay? And you want to know the probability of doing either one of those things or the other thing, then you add the probability and add the probabilities, and that's what mutually exclusive are events that cannot occur at the same time. The probability of two mutually exclusive events occurring, A and B, is the sum of their individual probabilities. Okay, A or B, right? So the probability of, say the probability of it raining this morning was 50%, even though it wasn't, okay? And say the probability that I would get in a car accident, no, that's morbid, okay? The probability that it rained this morning would be 50%, and the probability that I see my friend driving to school is 20%. What's the probability that it's going to rain this morning, or I see my friend driving to school? Or either this or that. What's the probability? Probability that it's raining this morning is 50%, right? Probability that I'm going to see my friend at school is 20%, so I could add those two probabilities together, and I get 70%. Yes? Yeah? Okay. Inclusive events are events that occur at the same time. And the way you find that is you find the probability of one event, find the probability of the other event, and then you subtract the overlap where both of those events occur. Okay, for instance, I can choose to go to University of Colorado, or I can choose to go to, what's the other one up there? CSU, okay? So, is that, and I can choose to go become an engineering major, okay? Let's just do these examples, okay? Problem 17. A bowl contains 6 white marbles, 2 green marbles, and 4 red marbles. What's the probability of randomly selecting a white or a green marble? Okay? Here, let's just look at these. then we'll be done after this, okay? A bowl contains six white marbles, 2 green marbles, 4 red marbles. How many marbles is that altogether? How many marbles altogether? 12, right? So what's the probability of randomly selecting a white marble? What's the probability? 6, right? What's the probability of randomly selecting a, what is the probability? A green marble? 2 out of 12. And if I add those together, right, I get 8 out of 12. So the probability of getting either or is 8 out of 12. And those are mutually exclusive events, okay? If 3 marbles are from the 12 without replacement, what is the probability that exactly 2 are red, okay? What's the probability that these are tricky. If a probability of random 12, what's the probability of selecting a red marble on my first shot? 4 out of 12, okay? What's the probability of selecting a red marble on my second shot? 3 out of 11, right? Now it says I want to have exactly 2 being red. So what, I need to pick that third marble, but I can't get a red marble. So how many other choices do I have? I can choose from the other eight marbles, right? I have to get either a green or a white, yes? So I have 8 out of, how many are left in the bag? 10, okay? However, this is where it gets tricky, right? This is if I go red, then another color, right? But I could also go another color, right? Then red, then, whoops, 4 out of, whoops, that's wrong. I could also go 8 out of 12, or then I have to get a red one, right? So now I have 4 out of 11, or I could go 3 out of 10, right? Or I could have got 4 out of 12. Then I could have gotten my non-red marble, which would now be 8 out of 11. And then I have to get another red marble here, which is 3 out of 10. Do you see that all these would give you the same number? Because I'm multiplying the same numerators and the same denominator. So what I would have to do is go this, all I have to do is multiply that times 3, and that would give you the probability of getting exactly 2 red marbles. Tricky, okay? If 3 red marbles are selected for a random from without replacement, what's the probability that all 3 are white? That one's easier. Who can tell me how to do that? Set it up for me. What's the probability that the first one's white? 6 out of 12. What's the probability that the second one is white? 5 out of 12? 11. What's the probability that the third one is white? 4 out of 10, right? So I think that's all we got to do there, right? Ian, do you know how to do these?
Yeah.
You do? Why are you on your cell phone? So is that why you're on your cell phone? Who's that guy on your hat?
Well, this is Tupac.
Tupac?
Yeah. You ever heard of Tupac?
No, but I've been doing a lot of sips, so I'm going to get a 6-pack. 6. I'm so funny. Okay. If 3. All right, well, we're just get through the rest of these problems, and then you guys can have some time to work. Okay? I'm sorry, I know it's kind of dry, but I like probability because it makes you think quite a bit. Okay? So 3 red marbles. Did I do that?
Yeah.
Oh, I did that. 3 dice are tossed. Whoops. I have to go tell Mr. Bieber that's right. Okay, so 3 dice are tossed. Let's try to do each of these. What's the probability that 3 dice show only 2 4s? Only 2 4s. 3 dice are tossed. Only 2 4s. So this is looking at what's the probability of getting a 4 if you throw a dice? 1 out of 6, right? And what's the probability of on the second dice having a 4? 1 out of 6. What's the probability of the third dice not having a 4? 5 out of 6. How many ways are there for this to happen? Just like that last problem. How many different ways can this occur? Right? If I think about it, right? Say this is a green dice. It doesn't really matter, a red dice and a blue dice, right? So here the green die shows a 4, the red die shows a 4, and the blue die does not show a 4, right? But I could also order it such that the green one, the red one the red one could, this green one could not show a 4. This one could show a 4. So there's 3 ways to do this. So what I have to do is put a 3 there. Here, give me your phone, okay? Thank you. All right. Let's put the phones away. Here, it's up here. Number 4. Here, number 4. Okay. Everyone put their phones away. Okay? At least 2 4s. If I want to get at least 2 4s, I can get this. So this probability, if I multiply this out, is 15, right? 3 times 5 is 15 over 6 times 6 times 6. What's 6 times 6 times 6? I'll tell you, it's 216, okay? At least 2 4s. So if I want to get at least 2 4s, I could also get how many 4s? 3. If I'm rolling 3 dice, what's the probability that I get 3 4s? What's the probability on the first choice? 1 out of 6, 1 out of 6, 1 out of 6. So this makes 1 out of 16, but then at least 2 4s means, or at least 2 4s means I could also get just 2. So then I have to add this in, right? So I'd get whatever this fraction is. Do you get that? That at least 2 4s? So I could get either 2 4s or I could get 3 4s, right? So if I add those together, this is 6. Is that 6 out of? Yeah, so this is equal to, this is 6. No. Why did I write? I meant 216. So it'd be 6 out of 216, right? Sorry, I got you confused. 6 times 6 times 6 is 216. Oh, 3 4s. This should actually have been here. This should have been 1 out of 216. What's the probability of getting no 4s? What's the probability of getting no 4s? Yep, it'd be 5 out of 6. 5 out of 6 times 5 out of 6 times 5 out of 6, right? And so that would be 125 out of 260. Yes? Right? So I think that's it. Is that it for this? That's kind of it for this. We'll talk, I think, I'll talk about expected value with like 20 minutes to go. Okay, so you guys can work on that. I didn't give you the second worksheet, or I did give you the second worksheet? I did not give it to you? Okay, so I have to get that. Where is it?